This video is very optional. I just wanted to show you that the quadratic equation doesn't sort of come out of nowhere. It doesn't sort of appear from outer space. It is derived. So we start with ax squared plus bx. By the way, there's lots of ways of deriving it. I think there's about 3 or 4 different ways. This is just the most common one. And we're going to do it by completing the square, which we've already done. First thing we're going to do is we're going to divide through by a. So then we get x squared equals b over a x plus c over a equals 0, because 0 divided by a is still 0. And then we're going to bring this term over exactly how we did in completing the square. Whoops. And we get x squared plus b over a x equals negative c over a. So far so good. Right, then what we want to do is we want to divide that by 2 and square it. So let's do it off to one side. B over 2a squared, because we divide by 2, and we get, when we open this out, over 4a squared. Right, so then we're going to add that to both sides. So x squared plus b over a x plus b squared over 4ac, sorry, a squared equals negative c over a plus b squared over 4a squared. Because remember, we can't just put this here from out of nowhere. We have to do it to both sides of the equation. All right. Now that that's done, we can do two things. We can now make our perfect square. So this is going to be x plus b over 2a square equals, and now the right hand side we're going to kind of multiply it out. So it's going to be minus c times 4a squared plus ab squared all over 4a cubed. Remember, top times bottom to top, bottom to top, bottom times bottom. And if we simplify that out a little bit more, we can see that this is going to be minus 4a squared c plus ab squared all over 4a cubed. And we can factor out on the top here an a. So we get an a minus 4ac plus b squared. And we can factor out an a on the bottom if you really wanted to, 4a squared. And they're going to cancel. And if you notice, if we rearrange this, we get our familiar b squared minus 4ac. Fantastic. So we have our x plus b over 2a squared equals b squared minus 4ac all over 4a squared. Okay, brilliant. Now we want to get rid of this 2 here, so we're going to take the square root of both sides. So that gives us x plus b over 2a equals the square root of b squared minus 4ac, because remember, if we take the square root, it's the same as taking the square root over the square root, over, now the square root of 4a squared is 2a. Test it out. 2a squared is 2a squared equals 4a squared. And now we're almost there. We can see this starting to come together. Like Hannibal said in the A Team, I love it when a plan comes together. So x is going to be, and I'm going to take this b over 2a across. So I'm going to subtract it from both sides. So minus b over 2a plus square root of b squared minus 4ac over 2a. They're over the same, a common denominator. So, and this is going to be plus minus, isn't it? But it doesn't matter there because we know that the square root of 4a squared is 2a. Minus b plus minus square root of b squared minus 4ac over that common denominator, 2a, and that's done. That's the quadratic equation. The good thing is you will never ever need to do that in the exam. If you need to do that in the exam, you're in big trouble. It is in the formula sheet that they give you. Very definitely is in the formula sheet that they give you. But just to show you that this doesn't kind of just not like Monty Python's foot coming down from heaven and squashing you. It does actually have a derivation. I don't know whether that was worth it, but that's how it's done.
Not too sure that was a clever move.